Now, let's move to our third chapter, that is, playing with surface mesh. Volume mesh generation in TGrid is possible from available boundary mesh. Boundary mesh required for grid generation is taken as an input from other softwares. Boundary mesh needs to be checked for defects and repaired to get good quality. Volume mesh is only successful with the good quality mesh. Moreover, bad quality meshes affect the accuracy of the solution in Solver. TGrid provides the user with different boundary repair operations and mesh quality improvement tools to play with the surface mesh. Let us have a detailed look into these mesh repairing tools. Outline of this course includes free and unused nodes, intersecting boundary zones, modify boundary, boundary improve operation, manage phase zones, refine boundary zones. Repairing boundary mesh involves merging free nodes, closing holes in the surface mesh, deleting multiple connected faces and edges. Improving boundary mesh involves swapping, smoothing, and remeshing. The boundary operations include the following options. Merge nodes. It reports free or unused boundary nodes and provides options for removing free and/or unused nodes. Intersect. It resolves intersections, overlaps, and gap-related issues in boundary meshes. Modify. It performs boundary repairs operations on boundary mesh. Wrap. This option uses wrapper technique to create good quality boundary mesh from a bad mesh. Mesh. It allows to improve, refine, remesh, or triangulate surface mesh. Zone. It allows to separate, project, or group phase zones. Manage. It allows manipulation of boundary zones. Create. It creates specific type of surfaces within existing geometry. Our surface mesh may contain free or unused nodes. Before proceeding for volume mesh operations, we should detect these problems and try to resolve them. TGrid provides automated operations to deal with free or unused nodes. Go to Boundary, Merge Nodes. You will come across Merge Boundary Nodes panel as shown here. As you can see in this panel, the free nodes in Compare group box of selected phase zone is compared with nodes defined in With group box. Boundary phase zones shows a list of all the boundary zones in the domain. Only free nodes. It takes into account only free nodes of selected phase zone. Set a tolerance as either an absolute value or percentage of shortest connected edge length. Percentage of shortest connected edge length is useful for meshes with widely varying sizes. Count the free nodes and merge them. Free nodes within the tolerance value will be merged. Count the unused nodes and delete them. Draw. It draws all zones that are selected in selection box. Message. Displays the message of whatever operations we performed. As discussed in the previous slides, Intersect option resolves intersections, overlaps, and gap-related issues in boundary meshes. Go to Boundary and then Intersect. It includes three basic operations, that is, intersect, join, and stitch. Intersect. It connects intersecting tri-boundary zones. Connections are made along curve of intersection. Refine sub option can be used to get good refined mesh near intersection. Join. This option is mainly used to connect the overlapping zones. The portion of overlapping surfaces within tolerance value will be joined. From the below given example, it is clear how this joining operation takes place. Stitch. Stitch operation connects the adjacent zones along free edges. The gaps within given tolerance is stitched using closest point projection. The points of nearest projection will determine the location of intersection curve. See the following example to understand the effect of stitching operation. Now, along with basic operations, there are some sub-operations available in Intersect panel. These are absolute tolerance. It allows the use of absolute tolerance. Refine. It is used to get good refined mesh near intersection. Separate. It allows to separate intersecting zones at the edge loop of intersection while performing any one of intersection operations. Now, as you can see here, the two ducts are crossing into each other, but they don't have any connection at nodes or at edges. To separate central duct into two parts at the intersection, we have used intersect option along with separate sub option. As an output, you will get central duct separated into two parts at an intersection with outer duct. Next, as you see, the two surfaces are crossing into each other. But here also, they don't have any connection at nodes or at edges. Hence, to bring about intersection and to refine the mesh near intersection, we have used intersect option along with refine sub option. As an output, you will get central duct attached with outer duct. But this time, the mesh of the outer duct is refined near intersection area. Now, let's move to the Modify Boundary option. Go to Boundary and then Modify. It will open Modify Boundary window. Modify Boundary. It performs boundary repair operations on boundary mesh. Different options available under this window are Filter. Different types of entities can be selected, that is, cell, face, edge, node, etc. After selecting one type of entity, change the filter type and continue selecting. Select the entity one at a time using the right mouse button from Graphics window. The selection will appear in Selections List panel. Using different operation buttons, perform the desired modifications. Skew Report Zone. cell zones of interest can be selected instead of identifying the locations of skewed cells for all zones. Enter selection. It allows to type the name of the object or zone or coordinates of position instead of selecting it in the graphics window. Now, below Enter Selection option, you will observe two sub-options, that is, Auto Redisplay and Local plus or minus delta. Here, Auto Redisplay option automatically updates the display after a boundary modification operation is performed. Local plus or minus delta option enables automatic display of skewed face along with some of the faces around it. Hotkeys up arrow and down arrow can also be used to increase or decrease the bound limits in the graphics window. In the graphics window, firstly, single-click with the right mouse button. Then, use up arrow hotkey so that graphics window will show skewed faces along with some of the faces around it. Each time you press the up arrow key, the layers around skewed faces will increase. Quality limit option allows to find face with worst quality in the entire grid. Mark option allows to find marked faces. Suppose, under Intersect menu, 25 faces are marked for stick operation to be carried out. Now, when mark is selected, the first of the marked faces will be displayed by clicking first in the graphics window. The selected node will appear in the selections list along with the longest edge of face and its opposing vertex node. Again, the hotkeys up arrow and down arrow can also be used to increase or decrease the bound limits in the graphics window. Now, let's consider the different types of boundary mesh repair operations. In this step, you will recreate the missing faces to repair the boundary mesh. Let's have a closer look into one of the missing faces. The faces surrounding the missing face can be highlighted to enable easy identification of the missing face. Enable Free in the Options group box in the Display Grid panel to highlight the faces surrounding the missing face. Select Edge in the filter list. Select the three edges surrounding the missing face using the right mouse button. If you select the wrong edge, click on it again with the right mouse button to remove it from the selection list. And finally, click Create in the Operation group box when the correct edges are selected. TGrid will recreate the missing face. The similar operation of missing face creation can be done by using nodes instead of the edges. For this, you select nodes in the filter list instead of edge. And then, again repeat the above procedure. In order to merge the two nodes, select the first node. This node position will be the final position after the merging of nodes. Now, select the second node. You can select n number of nodes. Now, click Merge in the Operation group box when correct nodes are selected. All nodes will be merged at the very first selected node position. In a similar track, we can use Collapse option. This operation collapses two nodes into a single node. Below Collapse option, you will see Move to option. Move to option moves the nodes to selected positions. Select node in the filter list. First, select the node which you want to move. Now, select position in the filter list. Your node needs the position where it wants to get settled. Hence, select the position using the right mouse button. And finally, click Move to in the Operation group box so that TGrid will move selected node to the specified position. Now, we will see how to modify the mesh by smoothing nodes. Click Next. TGrid highlights a face located in the middle of one of the walls. Select Node in the filter list. Select several nodes surrounding the face highlighted by TGrid as shown in the figure. Click Smooth in the Operations group box. TGrid performs node smoothing to make the surrounding cells as uniform in size as possible. In a similar way, you can do the splitting and swapping operations as shown in this slide. Now let's see what other options are available in TGrid and how they work. Rezone. It moves faces to new boundary zone. Clear. It removes selected object from selections panel. Delete. It deletes selected object from model. Undo. This option is used to undo previous operation. Move by. This option is used to move selected object by specified distance. Centroid. It finds the centroid of the selected object. Distance. It finds distance between selected objects. Set. It sets a line or a plane for use after project operation. Project. Used to project all selected nodes onto a set line or plane. As discussed earlier, TGrid generates volume mesh from given boundary mesh. Boundary mesh determines success of volume mesh generation and resulting quality of volume mesh. Poor quality mesh will cause convergence and/or accuracy problems. In order to improve the boundary mesh quality, we can use Boundary Improve panel. Just go to Boundary, then Mesh, and then Improve. The Boundary Improve panel will open. Under Options, the following options are available. Improve. It allows you to improve the selected zones based on the quality measure selected. It asks for quality limit, angle, and iterations. Elements for given quality measure above specified quality limit are improved. Preserve boundary. It enables preserving original shape of surface. This option is available when skewness, size change, or aspect ratio is used as a quality measure. Minimum relative size. All faces having area smaller than minimum absolute size value will be collapsed. This option is available with collapse and swap option under area as a quality measure. Try boundary zones. Try boundary zones contain a list from which you can select individual boundary zones to be improved. Try boundary zone groups. Try boundary zone groups contain a list of the default boundary zone types and user-defined groups. If you select a zone type or group from this list, all the zones of that type or group will be selected in the Try Boundary Zones list. You can also select multiple types to select all the zones of different types. Example, inlet and outlet. Next function available under Options is Smooth. The smoothing procedure involves relocating of the mesh nodes without changing the mesh topology. Enabling this option will ask you for following. Max angle. It is maximum allowable angle between two adjacent face normals. Relax. It is a relaxation factor for smoothing. iterations. It is a number of improving attempts. Now, the last function available under options is swap. If the unshared node on the other face lies within circumscribing circle of a selected face, then it is considered to be a Delaunay violation and the edge is swapped. Enabling this option will ask you for the following. Max skew. All faces having skewness greater than the specified value will be taken for swapping operation. Check. This reports the number of unused nodes in the console. Skew. Reports the face with the maximum skewness in the console. Limits. Reports the minimum and maximum area size in the console window for the selected zones. The Manage Phase Zones panel allows you to manipulate boundary zones. You can use the panel to change the boundary type of a zone, delete zones, combine or merge zones, display or draw them, print or list information about them, copy them, rename them, and change their position. In order to switch to Manage Phase Zones panel, go to Boundary and then Manage. Manage Phase Zones enables different options for manipulation. Phase Zones. It contains list of boundary zones. Phase Zone Groups. Contains list of boundary zone types and user-defined groups. Options. Here you will find different options for boundary zone manipulation. Those are Change Type. Changes boundary type of selected zone. Copy. Copies nodes and faces of selected zones. Delete. Deletes selected phase zone. Merge. It allows merging of selected zones. Then comes Rename. It allows renaming of phase zone. Flip normals. This option is used to reverse direction of the normal on face. Orient. Orient normal over a zone so that all are pointing on the same side of that zone. Rotate. Rotates selected zone through specified angle. For this, you need to give two inputs. Axis, axis about which the zone is to be rotated, and pivot, point about which the zone is to be rotated. Scale. Scales selected zone with given scale factor. Translate. Translates selected zone by specified distance. To use refinement regions for local refinement in some portion of the domain, you may refine the associated boundary zones as well. When you perform the local refinement, the boundary that faces that border, the refinement region will not be refined. It is therefore possible that you will have a jump in the face size, where a small cell touches a large boundary face. To improve the smoothness of the mesh, use the Refine Boundary Zones panel to appropriately refine the boundary zones that border the refinement region before performing the refinement of the volume mesh. Boundary refinement can be performed only on triangular boundary zones. In order to switch to Refine Boundary Zones panel, go to Boundary, then Mesh, and then Refine. Refine Boundary Zones refines boundary mesh and improves mesh quality after refinement. Refinement of zones is possible on marked faces or on proximity area. Select the zone to be refined and click Draw. The zone will be visible in Graphics window. Click Local Regions button to open Boundary Refinement Region panel. And then define Refinement Region around selected boundary zone. Adjust this refinement region around selected zone and click Define. The overall procedure will follow the path as shown here. Now, again go to the Refine Boundary Zones panel. The mesh in the defined refinement region can be refined using the option Refine under Options and mark as a refinement type so that the marked region will get refined as shown. The refined boundary mesh quality can be further improved. Select Swap in the Options list and specify the appropriate max angle and max skew values. And then click Apply.